started the recording again. So the last topic, which is quite short, is about how to use the serial port or serial monitor of Arduino. So on the communication function library or Arduino standard library on communication, it gives you the serial the port routines. So if I go there, I should, let's see, maybe I will go it like that. Arduino reference, and here serial, where's the USB, serial, communication, okay, serial. There's an excellent documentation of how the serial board actually uses and which serial port it actually has. So Uno has pin 0 and 1 dedicated for serial port. So as you can see, serial port pins RX receive data is actually on pin 0 and transmit data is on pin 1. In addition to that, there is a serial port engine on that chip which connects it to the USB. So let's go back. And there on the serial port you can do different functions. So serial.print function supports different data types, and you can then write easily information back to the host. So if this was done on real Arduino environment, then on that IDE there's a serial monitor that you can actually then send information or receive information. So basically this serial monitor shows what the Arduino is sending back, and then you can also send some stuff to the Arduino. And on the Tinkercad, okay, there's a serial monitor. On the Arduino IDE, there's that IDE monitor, but you can also access it using a separate terminal program. Okay. So that's the serial port. It's quite simple to use. So let's see how simple. I'll show you in a minute. But before that one, there's some additional stuff we added yesterday, thinking, okay, this might be a new stuff for some. First one is about the variable scope. If you have some variable defined outside of any function, then it shows up as a global for all of the functions on that code block it actually defined. Okay, in that case that z variable shows up also in function A. However, the later one, there's also on the function A, there's an internal variable which is local variable, which works only within that function and is actually especially within those parentheses there. So that's a code block, this code block, and the X can be seen only inside of this code block, which means that, for example, on printer function, if you try to print X, it doesn't show up. So, and that actually fails already on the compiler level. Okay, so that's about the variable scope. The upper level shows up on the lower one, but not the other way around. And then I already told you about this volatile variables on the beginning because that was a very good question there. And they're basically well, compilers heavily optimize the code. So basically, if you have an integer variable here, which is used inside of interrupt service routine, it does not necessarily work because the interrupt, this variable, the compiler does not really know how the variable is used, and then basically it can do bad stuff on the optimization. So the solution is actually define that variable as volatile. If you have any global variable inside of interrupt service routine, use always volatile type variables. And then it was the exercise time, and let's go on. We already have done some of the exercises on those sessions, and this was the exercise where I had that one the timer giving something on once or originally once a second. Let me take it back here. So this one does that blinking of the light once a second. What we could add here is also printing something for the serial monitor. Serial monitor can be found here. If you want to see some data, whatever the Arduino is sending, you can see it on this section, and otherwise if the Arduino can receive data, then you can just type the data here and send. Okay, that's easy. How about printing something here? And for printing, for example, we could print inside of here, print current value of toggle 1. Just for fun, to see that it works. So it's once a second operation, and serial interface functions are okay. Are there any serial? Okay, that would be basically just print. So that's serial dot print. How to call it? Okay, serial print and a number gives that one. That sounds quite simple actually. How about we just use serial print and that variable name there. So serial dot print and value is toggle 1. Okay, this actually will be printing just whatever I put there one by one. So 0, 1, 0, 1, 0, 1, so on. Oh, actually 1, 0, 1, 0, 1, 0 on one single line. There was also the serial print line command, but this might actually work. Let's see, does it work? Ah, I should probably see the serial monitor at the same time. Why it doesn't work? Maybe I didn't do something on the initialization. I have a feeling that it should be first initialized, but serial print, does it have any examples? Ah, yeah, of course. On setup, I need to say serial begin. Of course. And I've also, Let me also speed up it a little bit. Okay, there you go. Every time it blinks actually also prints the value of that variable on the serial monitor. So it wasn't a biggie. You just need to initialize it by saying serial begin and the bit rate. Okay, that works just fine. 9600, that's one of the standard bit rates. And then just have a place where to print it. Okay, good. So let me take a quick look at the exercise to see if I had everything there. I think Juho did pretty good job on this exercise, so it should be quite straightforward when you follow these instructions to do whatever is needed here. So do this kind of thing first. Implement the software using these settings. Then, okay, plenty of ideas can be found from there. Test that you can get this LED changes state when you press the button. Okay, that's measuring the latency. Okay, this is done. Well, you can see the connections. There's a oscilloscope. You connect the LED pin on one input and the button pin. So you have the connections there. Okay, these connections are still there. You just add this one into the previous design. And what this one actually does, this is old school stuff. You basically sum the signals using a simple resistor connection. So you can think of, okay, you take half of the whatever the Arduino pin is giving half of that signal, since that's 10 kilo ohms and this is the load for another 10 kilo ohms, and you also take another half from the this input pin, the same amount of it, sum it up and check it from the this oscilloscope. And what it actually gives you is something like that. Oscilloscope triggers when the signal is rising. So practically when this LED signal is going high or low. No, that actually the button is pressed. Yes, that's the higher signal there. Every time button is pressed, the signals rises. And basically then it's either falls or rises, depending on if this LEDs go lighting up or turning off. So on the left hand side we have a turning off signal, and right hand side we have lighting up LED. And this you can then measure depending on what is your setting on the oscilloscope. You can measure how many milliseconds, microseconds, nanoseconds, whatever they are, is the latency from the pressing of the pin to the actual change on the LED state. Okay, and you basically do that few times to see the variation. It's never the same, since the interrupt happens when it can happen anywhere on the code, and the instruction what it was doing is done first, executed first to the end, and then jump into the interrupt service routine, and it's always a little bit different time. So for latency measurements you need to do multiple latency measurements, and what is the longest and what is the shortest latency. Okay, then we have the timer interrupts, and okay, there are some of these. I wouldn't use that teach me micro. That gave me a nasty the pop-up window there. But the other ones, other, I think this Orliang and Arduino for projects, and then actually what was this one? Instruct tables, Arduino timer interrupts. That's also nice. Oops, oops. Huh? There. Those can be used there. And start from simple, one LED, continue from there. So the abstraction level actually rises when you're doing it. So following the instructions, this should be quite almost like a walk in a park. Third part is the using the button and serial monitor. And this is actually a simple way to debug a program without any higher end tools like JTAG emulation environments, that kind of things. If you have any communication channel on a processor environment, the most common one with embedded systems is the serial port. It's a common interface for anything. So basically you can then put prints at certain points of your program just for debugging. Just like if I wanted to see if this LED is really blinking or not, then I could actually put this one here and use that one as a debugging. Okay, it's going on and off and on and off. Works as required. And then basically, oops. Yep. So serial monitor. This is a simple code. Continue from part 2, add a button, remove the pull down resistors, do the physical connections, and then basically connect the button to get interrupts, and pressing the button will trigger an interrupt, and current value of the variable time is printed out on the serial monitor. Time refers to the time in the previous exercise, I think. Yes. There's a variable time here. All right, so that was today's topic. So in exchange of having, say, the circuits part was not that heavy, so but the Arduino part or the microcontroller part is now a little bit heavier. But anyways, this is very important part also on these embedded systems. Okay, and USB-C port of the embedded world? Not really. It's actually virtual USB port. It's renamed for no reason. Okay, so on embedded world, actually, you are talking about virtual serial port for debugging. Okay, good. So, any questions? In the exercises, can you do part 3 even if you don't do number 2? Well, not really. Not really. So basically, or actually you can if you make a, but then you don't have any points on this timer. So if you choose to make the timer part using delay function on main program, then you can do part 3 without part 2. But you don't get any points from part 2. So I would say try first to do the part 2. And remember that interrupts you learn only by one way, which is hard way. There are some tools on Arduino on these libraries that you could use on real Arduino environment, but it also kind of hides everything what is behind of it, so it doesn't go into fundamentals. So in that sense, this simulator, which does not support timer interrupts functions from libraries, is better since it really shows how these interrupt service routines work on processor level. So you need to access the control registers separately, set some pins, read that darn manual, and learn it hard way. Okay, good. Yeah, there's a good point of 4 points is less than 7. Yes. Okay, good. So have a nice day. Meanwhile, and yep, see you next week afternoon, Wednesday afternoon.